My name is Higgs and this is my friend Boson. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learned something new, latest and relevant. Isn't that wonderful, Boson?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe.
Today, we are reviewing a paper titled, Registration of Spatio-Temporal Point Clouds of Plants, for Phenotyping. Plant phenotyping is a central task in crop science and plant breeding. It involves measuring plant traits to describe the anatomy and physiology of plants, and is used for deriving traits and evaluating plant performance. Traditional methods for phenotyping are often time-consuming operations, involving substantial manual labor.
That's great, Higgs. The availability of 3D sensor data of plants obtained from laser scanners or modern depth cameras offers the potential to automate several of these phenotyping tasks. This automation can scale up the phenotyping measurements and evaluations that have to be performed to a larger number of plant samples and at a finer spatial and temporal resolution.
Yes, that is so intriguing, Boson. The registration task involves finding data associations between measurements taken at different times, while the plants grow and change their appearance, allowing 3D models taken at different points in time to be compared with each other. Registering plants over time is challenging due to its anisotropic growth, changing topology, and non-rigid motion in between the time of the measurements.
Researchers proposed a novel approach that first extracts a compact representation of the plant, in the form of a skeleton that encodes both topology and semantic information, and then use this skeletal structure to determine correspondences over time and drive the registration process. This process allows researchers to tackle the data association problem for the time series point cloud data of plants effectively.
This process was tested on different datasets acquired over time. It successfully registered the 3D plant point clouds recorded with a laser scanner. What is interesting, Boson, is this. This new method allows for developing systems for automated temporal plant trait analysis by tracking plant traits at an organ level. This was really an interesting paper to review. Hope you liked it as well, Boson.